All right, we are going to look at section 2.7 for chapter 2, which is looking at operations for different functions. And these are the notations that you're going to be looking at and see within questions, and you might have to flip back and forth to remember what they mean. For instance, if we look at an example here, we're defining the f function as being a linear function, and the g function as being a rational function, is x on the bottom. What will we get if we add f of x plus g of x? What will the result be? And if we try and do that, you can see when adding or subtracting, we're going to need to get common denominators. So what we would times here by is x minus 2, and in this by 3. And when we do that and we simplify, we get in the numerator this, and on the denominator remains the same, and you would get a final answer of x squared plus 5 over 3 bracket x minus 2, which is still a rational function, but combining that with the linear function, we find the numerator ends up being what appears to be anyways parabolic or quadratic. And you would find the answer similar for b when you subtract. When we see this, this means f of x times g of x. So we're going to multiply now our f of x times g of x. So f of x is, let me look back, x plus 2 over 3, and g of x is 3 over x minus 2. 3's cancel out, and we find we're left with x plus 2 over x minus 2. And if we look at, well, what's the domain of that? Well, we know it's all numbers except x cannot equal 2 because of the restriction. And in D, we would do division. Just make sure you multiply by the reciprocal. If you look in page 102 of your textbook now, there are two graphs on there. One is f of x, and the other one is g of x. And the example they do is adding the two together. What I have here for you is, well, what happens if we subtract one function from the other? So what I did is I look at each graph, and if I looked at f of x, I found what is the y value when x is 2? What's the y value when x is 3? All the way down, and I estimated those. And then I did the same thing with the g line, the g of x, when the x value is 2, 3, 4, etc. And I found them, and then I subtracted g of x from f of x. So the first subtract the second. Yellow subtract green leaves me with blue. So when I go to graph that now, my x value is 2, and I'm going to split this up into quarters, vertically anyways. And I might as well just go by 1, 2, 3, 4, 5, 6. So at x equaling 2, the resulting is minus 2.5. So minus 2.5 would be right there. And then negative 1.5 at 3. Negative 1 and a quarter. And I would graph those all, connect the dots, and that would be the graph of the two functions composed together with subtraction. You will also have, which is better said, is function composition, one function within another. So if we look at question A, what it is asking us is to find the f function after we find the value of the g function at 1. So what we would do is we would plug 1 into the g function, and we would get an answer. 4 over 1 minus 3 is minus 2. And then we would use the f function to find the value at minus 2. So we would replace x with minus 2, and we would get our answer. You've done it before. And you can do a variety of those. You can even do, if you look at question D, what's the g's function when you first find the g's function at value at 5. And the key thing is you start in the middle, work your way out. Not very hard. You will also find some abstract ones, such as f, which is the f's function value if the value is f of x. So within the f function, we replace f of x with what it equals. And then within the f function, we replace the x with x squared minus 1. And you would end up with that. Simplify it, get the answer. And you already know domain and range. So you got a shorter assignment here. I guess not as, I don't think this is nearly as difficult as the last section. If you get that done, you can start reviewing for your test, which will be soon. Have a great day. I'll talk to you again soon.